Welcome back to the Deep Dive. Today, we're tackling something that honestly sounds like it's straight out of science fiction, but it's becoming a really pressing challenge. For engineers, yes, but maybe even more for philosophers. We're talking about superintelligence, existential risk, and this kind of surprising need for philosophy in how we actually design AI.
It's a critical intersection.
Absolutely. And our sources today, they're pretty clear. Tweaking the AI we already have, that's not going to fix the biggest, maybe scariest problems. They argue we're facing something more fundamental, like a methodological failure, needing a whole new way of thinking about building these systems.
They're real paradigm shift.
Exactly. So our mission here is to unpack that. What does this new field, sometimes called Sophimatics in our reading, what does it actually look like, this blend of computer science and deep philosophy?
Well, to get us started, we really have to frame the core concern. Thinkers like Bostrom laid this out years ago, this idea of superintelligence. We mean AI systems whose cognitive abilities just fundamentally, irrevocably go beyond human intelligence.
And the danger isn't necessarily like malevolent robots.
Not necessarily, no. The core danger is simpler, maybe more insidious. Once these systems get highly autonomous, our sources warn, they pretty quickly become uncontrollable, practically speaking, and that could lead to outcomes that are, well, really bad for humanity, even if the AI wasn't trying to be harmful.
Okay, so that brings us to the alignment problem.
Right. The challenge isn't just making the AI smart, it's making sure its goals align with our goals, human values, which are messy, complex, sometimes contradictory.
And they stay aligned, right? That's key too.
Crucial, because the purely technical approach, well, it keeps falling short on guaranteeing that alignment. So the proposal on the table is this new approach, Sophimatics, grounded in philosophy, providing that ethical, contextual framework right from the start.
Okay, let's dig into the urgency here.
Okay.
Because we're not just talking about better chatbots. We're talking about what Bostrom called an intelligence explosion.
A runaway process.
Yeah, a rapid, almost unpredictable jump in capabilities. When a system can improve itself faster than we can even follow its changes, well, we lose the ability to predict what it'll do next or manage its goals.
Which might diverge significantly from what we intended.
And here's where it gets really fascinating, I think, for you listening. The unpredictability isn't just because the systems are complex. That's part of it, sure. But it's also because we genuinely don't fully understand how these systems interact with the world, how they adapt.
We lack that deep knowledge.
It's like the train is moving incredibly fast, but we can't see the tracks ahead, and maybe the train is laying down new tracks as it goes.
That's a good analogy, and it really highlights the failure, or at least the limitation of the traditional AI development path we've been on. The focus has been so heavily on performance metrics, speed, efficiency, how well it does a specific task, generating text, spotting patterns, whatever.
And the side effects, the ethical alignment.
Often treated as secondary. Something to fix later, maybe. A post hoc patch rather than a core design principle from day one.
Which brings us to the black box problem. That term gets thrown around a lot.
It does, and for good reason. With current deep learning, these neural networks, they're incredibly complex. You put data in, you get an output. But the actual decision-making process inside, it's often opaque. Humans, even the programmers who built it, can often only guess why the AI made a specific choice.
Okay, so why should you, our listener, care if some algorithm can't explain itself? It's not just academic curiosity, is it?
Not at all. It fundamentally undermines accountability. If an AI system makes a catastrophic mistake, say in finance or healthcare, and we can't trace the reasoning path,
Then we can't reliably fix it.
exactly. We can't guarantee it won't happen again. We're essentially flying blind when it comes to ensuring safety if we can't understand the root causes of failure.
Okay, let's make this really concrete.
Yeah.
You mentioned side effects. Give us a real-world example where just focusing on technical performance proved dangerous.
Well, our sources point out that while AI is amazing at pattern recognition, planning, self-improvement in narrow domains, it consistently struggles with context, with genuine understanding. And it often amplifies biases present in the data.
Right, the bias issue is huge.
It is. And this lack of contextual intelligence isn't just theoretical. It has had devastating real-world impacts, especially when AI gets deployed in the public sector, making decisions about people's lives. You often see discriminatory, unethical outcomes. Not because the AI is malicious, but because it's great at spotting patterns in data, but terrible at understanding the meaning or relevance of those patterns outside the dataset's narrow confines.
So the Dutch childcare benefits scandal fits here.
It's a stark, heartbreaking example. This wasn't about slow code. It was a fundamental failure of contextual reasoning. The system used complex algorithms, yes, but on datasets that didn't properly represent family situations. It lacked crucial contextual information.
And the result?
The algorithm, working correctly based on its flawed data and narrow rules, wrongly flagged thousands of families for fraud.
Leading to financial ruin for many.
Exactly. Massive harm. It was effective at finding statistical outliers, but completely incapable of understanding the human context needed for fair judgment. It basically automated and amplified discrimination through its own complexity.
That's sobering. It really drives home that contextual intelligence can't be an optional extra. It has to be baked in.
It has to be central.
And this isn't just an old problem. Even the latest, most advanced models like GPT-4, they still struggle, right, with context.
They do. Our sources show that even these powerful large language models have issues with basic contextual understanding, especially things like temporal relationships, understanding sequences of events, or satisfying multiple constraints in a complex request.
There was a finding about complex tasks.
Yeah, quite a striking one. In tests on complex tasks with multiple specific constraints given by users, less than 1% of the outputs actually met all the constraints.
Wow, less than 1%.
It shows that despite their fluency with language, there's a fundamental weakness in really understanding and following complex rules or real-world relationships. Push the complexity, and the contextual grasp tends to break down.
Okay, so if just pushing for better performance isn't the answer and might even be dangerous, what's the alternative? How do we actually build safer, more aligned AI?
Well, the core difficulty, as we said, is encoding our complex, nuanced moral values. Human ethics aren't simple rule sets.
No, definitely not.
And this, the sources argue, is where we need philosophy. We need insights into how humans reason, how intention works, things computer science on its own doesn't traditionally deal with.
So it's a combined approach they're recommending.
Yes. Bringing in ideas from philosophy and cognitive science and marrying them with new types of AI architectures. Architectures designed specifically to align behavior with human morality.
Okay, now philosophy can sound pretty abstract. You mentioned Kant and Husserl. For our listeners who maybe haven't brushed up on German idealism or phenomenology lately, how do ideas like Kant's a priori structures or Husserl's intentionality actually translate into building AI?
Let's try to simplify Husserl's idea of intentionality. It basically means that our thoughts are always about something. They're directed towards an object or a goal. If you apply that to AI, you're talking about explicitly modeling the purpose behind an action. The AI shouldn't just do something. It needs a model of the user's intent. Why do they want this done? That's crucial for alignment. Does the action actually serve the intended purpose?
Okay, so building in purpose awareness. What about Kant, those a priori structures?
Kant talked about innate categories that structure how we experience the world: space, time, causality. The AI translation is about building in a kind of structured world model from the start. Think of it like a modular, layered knowledge hierarchy. Some sources connect this to older philosophical ideas too, like Aquinas's layered concepts. You essentially give the AI a pre-built conceptual framework to help it organize information before it even starts learning from raw data.
So it's not just learning patterns from data, it's having a built-in structure that forces it to think about things like cause and effect or categories of objects or maybe even intentions.
Exactly. It forces a degree of contextual organization rather than just relying on statistical correlations, which might be meaningless or harmful.
Which leads us to the technical side, cognitive and hybrid AI. This sounds like the engineering solution built on that philosophical foundation.
Precisely. We move away from the pure black box connectionist models, the ones that are powerful learners but opaque. Hybrid AI combines those connectionist parts, which are great at learning, adapting, finding patterns in data.
The sort of intuitive pattern matching part.
Right. It combines that with symbolic processes. Think of this as the more logical, step-by-step reasoning part, the kind we can actually read, understand, and explain. It's explicit.
So like two different kinds of thinking working together.
Kind of, yeah. The hybrid model makes them work together. A model like Sun's Clarion is mentioned as a key example.
How does that Clarion model work, roughly?
It uses a connectionist part for the low-level learning, pattern recognition, but it also has a symbolic part for higher-level reasoning, motivations, explicit rules, and crucially, there's knowledge transfer between them. The system might learn a pattern implicitly, connectionist, but then it can extract that knowledge into an explicit readable rule, symbolic, that can guide its decisions.
Ah, so it makes the learning explainable, at least partly.
Exactly. Effective and explainable, that's the goal.
And this layered design you mentioned, borrowing from Kant or Aquinas, that has practical benefits for control, right? For oversight.
Huge benefits. If you structure the AI's knowledge hierarchically from raw sensory data up to abstract concepts like intention, function, maybe even emotional tone.
They get different levels to work with.
Right. You get granular control. The whole system can manage behavior across these layers. A simple action like grasp or a complex one like approve loan application can be broken down.
And the safety aspect.
Because parts of the reasoning are symbolic and explainable, you can build in explicit checks and balances at different layers. You can have the system essentially ask itself, if I proceed with this action recommended by the connectionist part, does my symbolic reasoning predict it might violate a core principle or lead to harm? If yes, it can stop itself.
So it can halt autonomous actions before they escalate into something bad.
That's the key safety mechanism. It provides a way to intervene based on understandable rules and predicted consequences, stopping runaway behavior.
Okay, that sounds promising. A path towards building safer AI. But the technology is only one piece, right? The whole governance environment needs to adapt too.
Absolutely. Even with better architectures, if our governance structures are weak, we still have problems. And we see issues even now with advanced systems like GPT-4.
Like the calibration problem.
Yeah. Their stated confidence in an answer often doesn't actually match how accurate that answer is by objective human standards. They can be confidently wrong.
Which is dangerous if we rely on them for critical decisions.
Very dangerous. And this ties into ethical self-awareness, too. Current research suggests these systems, as they are now, can't achieve robust, multi-level self-awareness, especially regarding ethical alignment. People are trying techniques like social context debiasing, basically trying to teach the AI about moral obligations, and they can suppress some bias.
But it's not enough.
It seems far below the level needed for genuine, reliable, higher-order moral reasoning. We're not there yet.
And on the governance side, are current methods working? Things like AI ethics principles?
The evidence is not encouraging. The dominant approach is principle-based. Companies put out these statements about fairness, transparency, accountability, but research shows this often ends up being what's called principle washing.
Principle washing, meaning?
Meaning the principles are vague, they're non-actionable, there are no specific metrics, no real accountability tied to them. They sound good on paper, maybe provide some PR cover, but they don't actually change how the AI is built or deployed in practice.
That's a strong critique. If principles, which sound like they should be the foundation, don't work, what does? Are we saying governance is just failing?
The sources argue the current form of principle-based governance is failing because it's disconnected from the technical reality and lacks teeth. There's no mechanism for enforcement or measurement tied to the actual system behavior.
And there's inertia. People aren't fixing this.
Worryingly, yes. One review mentioned found that attention to these core AI principles in research and corporate literature actually declined between 2018 and 2022.
Declined, even with all the AI controversies happening then.
Exactly. Despite major issues hitting the headlines, the focus on operationalizing these principles seemed to lessen. It suggests the industry isn't making the deep, systemic changes needed. The old paradigm is still dominant.
The paradigm focused just on capability.
Right. Optimize the tech, make it faster, more powerful. The context, the impact, the philosophy still secondary. And that's why the call for this methodological shift for something like Sophimatics is so urgent. It forces us to consider the human, social, environmental context first, to combine philosophy, social awareness, and technical constraints with continuous monitoring and adaptation built in.
So that really is the key takeaway for you, our listener. Getting to safe superintelligence isn't just about writing better code or having faster processors. It demands better ethics, deeper philosophy, baked into the system design from the absolute beginning, forcing the AI to grapple with context and consequences, not just optimize for a narrow technical goal. It's shifting from can we build this to should we build it this way and how do we ensure it remains aligned?
And that leaves us with a really crucial question for you to think about. Given how hard it is to actually encode complex moral values and seeing how common this principle washing is, what concrete, measurable steps beyond just publishing vague principles, what kind of mandatory, verifiable accountability would you demand from any organization building the next generation of truly powerful AI? What would actually convince you they're taking safety and alignment seriously?